Okay, in this example, we're going to solve the inequality x squared minus 4 is greater than 0. To do that, we're going to solve it by graphing here, and we're going to do the same sort of thing that we did before when we solved equations by graphing. And that's going to be graphing each side as its own equation. Y equals x squared minus 4. And the other one, which is y equals 0. Now this actually already has the graphs for us. X squared minus 4 is already there in green. And as far as y equals 0, that's just the x-axis. It's a horizontal line where the y values are 0. So horizontal line right there. Okay, now to do this, I'm going to look for the intersections. So we have two intersections here and here. And I'm going to use a similar approach to what I did for increasing and decreasing and positive and negative. So I'm going to draw vertical lines at those intersections. This separates the graph into three pieces. The first piece is between negative infinity and negative 2. Second piece between negative 2 and 2. And third piece between 2 and infinity. You'll notice I didn't put any brackets or parentheses around it this time. And that's because the brackets and parentheses is determined by the inequality sign. Since it's just a greater than sign, no equal to, there's going to be parentheses around everything. Now to figure out which ones are the solutions, since we're looking for the ones where x squared minus 4 is greater than 0, that means x squared minus 4 has to be above 0. Whichever one is the greater than has to be on top. So if you look at the first section here, we have x squared minus 4 here and 0 here. X squared minus 4 is above it, so this first region is one of the solutions. Second region, here is where 0 is. X squared minus 4 is below it, which means it's less than 0. So we don't want that region. In the third region, x squared minus 4 is here, and you can see that that is higher than the 0. Therefore, that is again a solution. We're looking for the ones where x squared minus 4 is greater than. So we have two regions that are solutions. Negative infinity to negative 2. And 2 to infinity. Remember that you can also see your answers written out in different ways, including inequality form, like this. As well as getting rid of the infinities. So there's a number of ways the solution can actually be represented. Okay, in this example, we're going to solve the inequality x plus 3 is greater than 7 minus 3x by graphing here. We already have the graph given to us, so we just need to figure out which line is which to start with. If you look, we have x-intercept of 3 for the green line. Y-intercept of 3 for the green line. And you can see the first piece is x plus 3. So that means this green line is that first piece. I'm going to try to keep the colors the same. So y equals x plus 3 is my green line. And that makes the other one, the purple line, y equals 7 minus 3x. I'm going to label like that. Okay, so now that I have that straightened out, we're going to go ahead and separate the graph. Since the solution is right there, or the interception is right there, we're going to split the graph at the intersect. This separates the graph into two segments. we have the segment over here on the left between negative infinity and the x value of 1. And we have 1 to infinity for the other one. Kind of read that a little bit close. It's still parentheses again because we just have the greater than sign. Now if we look at the inequality here, helps to figure out which one is supposed to be greater than. So x plus 3 is the greater. So we're looking for the regions where x plus 3 is higher than the other equation. So we want the green one to be above the purple one. In the first region, the purple one is right here, which is higher than our green piece. So that is not the solution we're looking for. In the second region, we have the green one up here, which is above the purple one down here. That's what we want. We want the green one to be higher. Because we want x plus 3 to be greater than. So this region, 1 to infinity, is our solution. Again, you can also write it out. It's 1 less than x less than infinity, or x greater than 1, a number of ways to represent the answer. So, whichever way, so long as it's equivalent, is good. So in this one, we're trying to solve the inequality 2 times the absolute value of the difference of x minus 1, the minus 3 on the outside, is less than or equal to 2/3 times x minus 1. So to do this, we first need to figure out which of the graphs is which. And we have one absolute value and one linear piece, which means the absolute value, which is graphed in black, that V shape, is going to be corresponding to our absolute value function. The one in black is my y equals 2 absolute value of x minus 1 and minus 3. And then the one in red has to be the other one, which is y equals 2/3 x minus 1. Just like I've done before, I'm going to find the intersections, which are here and here. And I'll draw vertical lines at those spots to help me out with it. So there and there. This splits the graph into 3 regions, from negative infinity to 0. This time I will be having square brackets because our inequality sign is less than or equal to. So the next region is from 0 to 3. Again, everything will be square brackets except the infinities because you can't include infinity. And from 3 to infinity, square brackets this time because of the less than or equal to. The equal to part is what gives us the square brackets. Okay, now that I've split my graph up, we just have to figure out which one matches the inequality statement. So in this case, we're looking for the one where the 2/3 x minus 1 is greater. Just based on the inequality sign. So we want the 2/3 x, the linear piece, the red one, to be above the black one. So if we look at the first region, you can see that the black one is up here while the red one is down here. We want the red one to be above. Red one is not above in the first region. So first region is no good. Second region, we have our red one right here. That is higher than my black one. So that is good. So 0 to 3. And then the third and final region, my black one is up here. My red one is below it, we want the red one here to be higher than the black one, because we need the red one, the linear piece, to be greater than. And it is not, so this is not a solution as well. So the only solution we have is from 0 to 3 inclusively, or 0 less than or equal to x less than or equal to 3. Just as a different way of writing it.